Hello, pre-calculus students. In this chapter, we're going to start our part on coterminal and reference angles. Section 4.1. So our benchmark here is to use mental mathematics, properties, and numerical relationships to graph basic types of functions with the aids of tools as computers and calculators. I can apply knowledge and sense of numbers to solve and represent basic functions of absolute values, square root, linear, quadratic, trigonometric functions to describe numerical relationships. The objective here in this lesson will be to introduce the angles of rotations and to know how to find coterminal and reference angles. Okay, so on the past courses, you have been talking about that angles are raised united by a common vertex and they have a degree of elevation or depression. And we have been talking about trigonometric ratios. Sometimes angles will not be able to fit on a triangle, just like we've been practicing with trigonometric ratios. So we decide to put this and practice what we call the standard position of an angle, in which basically what happens is that when we have an angle in standard position, we'll start with the vertex at the origin of this Cartesian plane, and then we'll start here on the positive side of x, and we'll move it as is indicated here. When we have positive angles, it's going to rotate counterclockwise, and when we have negative angles, it's going to be clockwise rotation. So if we just remember, this is our 0, this is our 90 degrees, this is our 180, and this is our 270, and a full revolution would be 360 degrees. Okay, so when we try to do our rotation here, it says 225. It's a positive angle. It's counterclockwise. So we go ahead with the initial side and we say, okay, here we have 90 degrees. Here we have 180 degrees. And it says 180, right? So it says 225. So that would be like 45 more. So we'll say that our terminal side is about here. Okay, and we will write here 225 degrees, 225 degrees. Okay, so this was our initial side that is always at the origin. Okay, and this is our terminal side, and because it's positive, it's going to be against the hands of the clock. Now we have our second example, negative 170. Once more, we have here the origin at 0. We have our initial side on the x-axis, positive side of the x-axis, and because it's negative, it's going to be clockwise, and it says 170. So this is 0. And we already know that the first quadrant is 90, 180, 270. But we know since it's divided in 4, it doesn't matter. We still have those 90 degrees here, right? So we would say 90 degrees. And then it says 170. So if this is 180, we would have 10 degrees less. So it's gonna, our terminal side is gonna be here, and it's clockwise. So this would be negative 170 degrees. So this is how we would be practicing and sketching angles in standard position. Now look at this one. This one is 480, and it's negative, so it's gonna go it's going to go a little bit more than one revolution. So we'll start here on the vertex, our standard position in the positive side of x. And then we already know that we have to do a complete revolution because it's already 360. Okay, so we are going to continue and add 90 more, and 360 plus 90 is 450, and then 40 more would be 480, right? 480 degrees. So we made a complete revolution, 360. This would be 450 here. And 480 would be 30 degrees more. So we come and we add our terminal side here. Let me fix this one here a little bit. And this should be our negative 480 standard position of this angle. Now, not every time are we going to have angles in degrees. We can also have it in radians. Now, our common denominator here is 6. So that means that I have 0 degrees. I have a 2 pi here. I have pi halves. Right? And if I want like an equivalent fraction of that, which has a thing of 6, I should multiply 3 at the top and at the bottom. And 3 pi 6 is the same thing as pi halves. 2 pi is the same thing as saying 12 pi 6 if we want everything to have like the terms of 6. Right? If this is 12 pi 6 and this is 2 pi and this is half, this is pi, but since I want it in terms of 6, I could say 6 pi 6. Okay, and this one is 3 pi half, but if I want it in terms of 6, just remember a little bit what we practiced with the nine pi 6. So I already have all my radians. And what they want me to do is 5 pi 6. So I know that it's going to go against the hand of the clock. And I'm going to do here my origin, standard position, 0. And then it says 5 pi 6. If this is 5 pi 6, that means that's actually 1 pi radian before. So this would be my terminal side, and this would be 5 pi 6. And if you want to make sure, you can also use your conversion factor with the pi, 180 over pi, and put it in degrees and see what it is, just to make sure. So this is the practice of standard position. Now we're going practice a little bit what are coterminal angles. To make it a little bit quickly, coterminal angles are those that have the same initial side and the same terminal side. So we're going to refer to coterminals as two angles in an extended measurement system that have the same initial side and the same terminal side, yet they have different measures. Now, what are the two ways in which we can get coterminal angles? We can get coterminal angles either by adding or subtracting 360 or adding and subtracting 2 pi. So already having the knowledge of what is a coterminal angle, let's go ahead and let's find a positive and a negative angles that are coterminal with 45 degrees. Okay, so what are we going to do? According to what we've learned, we can add or subtract 360. So we can get as much as we possibly can. So we could say 45 plus 360, or we can say 45 minus 360. So let's solve the first one. What would be 360? What would be 360 plus 45? So we could say here that our coterminal angle would be 405. Okay, and then we have this other one here that would be 45 minus 360. (45 minus 360). Which would give us negative 350. Okay, so you guys can understand the concept of what I said. with the ending and the initial side here. Okay, we already know where our 45 degrees would be. This is our initial, right? And it says here that 45 degrees is this one here. Okay, so this would be our initial side and our terminal side. That would be 45 degrees. So that then it says that it's 405, the other one. So it's positive. That means that it's counterclockwise. It has 180, 270, 360, okay, and 45 more. That means that we'll also end up here. So here we have 405. So if you guys see both the angle 405 and 45 have the same initial size and have the same terminal side. Same thing if we were to do it clockwise, sorry. Okay, if we have here 45 degrees, we start again here just because, okay, this is our 45 degrees. And I want to do negative 315. So this would be our starting point. Again, same initial side. Okay, 90 degrees, 180 degrees, 270 degrees, right? And this would be 315 negative, right? So if you guys see both 405 and negative 315 have the same initial and terminal side of 45 degrees, and that's what we call coterminal angles. So you guys can see here my 405 and my negative 315, and you can go ahead and keep getting more, right? More coterminal angles. Why? How do you do it? You keep adding 360 and you keep subtracting 360 and you will get the same thing. So another coterminal angle that, or another angle that will end at the same side and start at the same side would be 765. And then this one, the negative 350 minus the 360, you would get 675 degrees negative, right? So this would be the coterminal angles here that would have the same initial side and the same terminal side. We could also find coterminal angles with radians. And how do we do it? We add pi. We add. So we could, and we could subtract. So we can say pi 6 plus 2 pi and pi 6 minus 2 pi. And you can keep adding and doing it again. So when we add the 2 pi, you get 13 pi 6. Remember that this one we find when we do this basic fractions, but we're gonna go over it just in case you forgot, right? We use common denominators, and remember that that multiplies at the top and at the bottom. So this one is just like having a 1 here. Let's switch that one up. This one stays the same because we're not changing it. And then this one becomes a 6. So that 6 multiplies at the top and at the bottom. And this one becomes 12 pi, right? So 1 times 6 is 6, and 6 times 2 is 12. 12 plus 1 is 13 pi 6, what we have here. Same thing for the subtraction. If we have pi 6 minus 2 pi over 1, we have the pi 6. And then we subtract the 2 pi. So we are actually subtracting the 12 pi 6. And we take the sign of the greater, and that gives us the negative 11 pi 6. Okay, so now you guys are going to practice, and you're going to find a positive and a negative coterminal for each of the following. 13 pi 6, a positive and a negative coterminal. You add and you subtract. So this one equals 13 pi 6 plus 2 pi over 6. That gives us plus 12 pi over 6 or minus 12 pi over 6. So the first one added would give us 25 pi 6, and the other one subtracted will give us pi 6, 11 pi 6. And then 3 pi 4 plus 2 pi plus or minus. When you guys do it, remember that that 2 pi can be rewritten as if we want to have the denominator of 4, then we can put a pi 4s, right? The 2 pi. So what happens here is that you would have 3 pi 4s plus 8 pi 4s. And that's what gave you 11 pi 4. And if we want to write 2 pi, remember to write 2 pi as 8 pi over 4, but you subtract 8 pi over 4. So when you subtracted 3 minus 8, that gives us 5 pi 4, but negative because the sign of the 8 pi is greater. So that's how we do it. Okay, now a little bit about complementary angles. The complementary angles are two angles whose sum is 90 degrees or pi halves. So if we ask you about that, we would just have to, or supplementary angles are the ones that have 180 degrees if we add both, or pi. So these are something for us to remind ourselves when we're converting angles. Okay? Find the complementary and supplementary angles for 2 pi fifth. So it says here that if it's 2 pi fifth, we would have to add pi. Okay? That the two of them added together should equal to pi half. So if I want to find out the missing piece, I have to subtract pi halves minus 2 pi of 2 pi fifth, sorry. So we get here 5 pi over 10 and 4 pi over 10. We converted by finding the least common multiple. So that would be 10. So 2 times 5 gives me 10, and 5 times 5 gave me 5. 5 times 2 gave me 10, and 2 times 2 gave me 4. So a complementary angle would be pi tenths in radians. And we can also, if we want to find the supplementary angle, we subtract from pi. So we say pi minus 2 pi over 5. Now, I want something that is the equivalent to that pi. And because this one has a denominator of 5, I could actually write a pi as 5 pi over 5. So that would give me 3 pi fifths. Now, what are reference angles? Reference angles are important angles in trigonometry. It's an angle whose terminal side is closest to the x-axis. All right. For example, if and we have like little rules here that's gonna help us a little on this. If your terminal side of the angle is in quadrant 1, then our reference angle is going to be the angle that you have. So for example, if I have 45 and 45 is in the same quadrant, then my reference angle would be also 45. Why? Because it's in quadrant 1. If your terminal side is in quadrant 2, let's say that I get 105. 105 is on the second quadrant, just for us to to give like a little example. Okay, on the first one we said if it's in quadrant 1, then it's the same angle. So if I have to find the reference angle of 45, 45 is on the first quadrant, so that means that my reference angles is still the same, or 45 degrees. Now, if my angle is 105, when I draw my angle, so you guys can get like a little idea of a fast one here. This is where I start remember initial and terminal size. This would be like my 105 angle. Not that great, but you guys get the idea. So this one ends on the second quadrant. What does it say? It says then I find my angle by subtracting 180 minus the angle. And it also told you at the beginning that is the difference of where my angle touches, right, the x-axis. So this is like my small triangle. All right, so this one says 105. So 180 minus 105 would be 75 degrees, right? So that would be my reference angle, 75 degrees. And then it says if your terminal side is quadrant 3, then your angle would be fine, your angle minus 180. And if your terminal side is in quadrant 4, then your angle is fine by 360 minus your angle. All right, so this would be it. Now let's see here an example. Okay, so we're going to calculate here the reference angle. So it says here 150 degrees. So how do we calculate that? We're going to draw the angle here of 150 degrees. So if you guys see here, we start always from the vertex at the origin on the positive x axis. Okay, then we said this is 0, this is 90, and 90 degrees. This is 180. So because it's positive 150, we're gonna go counterclockwise. So this is 90 and this is 150. We take out our terminal side here. And then we're going to figure out what our reference angles is. So there are two things that we have to remember. Our reference angle is the angle that is closer to the x-axis. So here we're missing like 30 degrees to finish in the x-axis. That would be our reference angle. So the reference angle would be 30 degrees. The other thing is that our reference angle, when it's on the second quadrant, we will subtract 180 minus the angle. In this time is 180 minus 150. So again, it gives us the 30 degrees that we have here. On the second one, we have negative 20. Okay, so this was our A. Now our B says that negative 20, and we want to find our reference angle. So this is what we're gonna do. We have negative 20. This is our origin. Okay, and it says here that is clockwise. So this would be our 20 degrees. Now it has to be the one that is closer, right, to the x-axis. So here what is closer, it would be again 20 degrees, right? So our angle here would be 20 degrees. The other thing is that when it's in the fourth quadrant, we could actually make like a coterminal angle and find it. And we could say negative 20 plus 360. And that gives us that this is 340 degrees. Right? So if we were to make that one again and we did it clockwise, we would find out that 340 degrees would be around here. And when we have it on the fourth quadrant, we would subtract 360 minus the angle that in this case is 340. So again, By that method, it also gives us 20 degrees. Okay, and then I believe we have the last one, which is negative 545. This one is a humongous angle. So what we do is that we usually find a coterminal angle for it and graph it and find the reference angle, right? So we are going to add the negative 545 plus 360. And then we're going to find our answer there, negative 545 minus 360 or plus 360. And that would give us 185 negative. Okay, so we do it clockwise. The 145. This is 90, 180, 185 right here. This would be our terminal side. So these are 5 degrees. And that's the closest angle to the x-axis. So according to this, my reference angle here should be, sorry, right, the 5 degrees that I have here, right? F reference angle. Okay. All right. So now you guys have like a little exit path to complete in class. Make sure that you review the concepts and that you enjoy this video. Thank you very much for attention and have a good day.